Time start. Welcome to the course 1DV607, Object-Oriented Analysis and Design using UML. This is the first lecture I have, not counting yesterday's in Växjö. We had a small introduction to the tools and process of studying in a distance-based course. I guess you are all familiar with this already. So let's get started. My name is Tobias Olsson. I will try to look at the chat as much as possible, but we will take a short look at the course homepage. I hope you have found it. I hope you have registered. I have a bunch of registration problems in Växjö with different course codes and students and stuff like that, but I hope most of you at least have been able to register for the course. As of now, we are 84 students, and I have like 20 students on a special list with problems, so we will be quite a lot of students on this course. So you are reading it, and the Växjö computer science programs are also attending this course, which is good because you can get a lot better feedback and make new friends and stuff like that. Turn down the mic a little, it's a little clipping. Okay, I will try to do that. Okay, I need to stop the sharing, I think. Okay, I hope this is a little bit better. As usual, we are recording this. Slides and materials will be presented on the course homepage. This is nothing new to you, I guess. This is oh, how slow it is. This is the lecture plan, at least. I'm hoping that we will get a little bit ahead of plan, especially in the beginning. So today and tomorrow we'll be focusing on introduction and domain modeling, and well, we will probably have to make adjustments as we go along. But this is the plan, and we will have 13 lectures. I think we have 14 in the schedule, so we do have some buffering time, which is good because stuff can always happen along the way. If stuff happens, I will post it on the course homepage as soon as I know if a lecture is cancelled or a tutoring session is cancelled or something like that. This is also connected to the Slack account, so you should get a notification there whenever something is posted here. So do use Slack and do check the homepage before the lectures, because you never know. As I said, my name is Tobias Olsson. I've been around the university for 12 years or something like that. Before my teaching, I worked at Massive Entertainment doing computer games, and I also worked at ABB Robotics doing robotics simulation software. Quite similar, actually. But I've been here at the university for like 12 years, so a lot of teaching. I teach mostly computer science, of course. This course is one of my favorite courses. I find analysis and design challenging and fun, but I also have project courses, so some of you will meet me again in the spring. And of course, some thesis work with you especially in the third year, if you attend that. I have a family. I live here in Kalmar, and wife, kids, dog, car, house, the whole enchilada. And my kids have just started school, so they tend to get sick in the beginning. So stuff can happen with very short notice. So check the homepage if something is cancelled. Otherwise, I think you recognize the homepage from different courses you have attended. We have a little bit about course management, where you can find ways to contact me. Course literature is good to check out. We have the book Applying UML and Patterns. I don't know if you have already got it from previous courses. I think it's from some of the programs have already had this book. So we have a few chapters that are vital in the course, and some other chapters that are not that important but could be good to check out to get the whole picture. We have a couple of examples in the book that I think are really good, so look at those. We have a Monopoly game, a point of sale system, and a persistence framework that are designed and analyzed and implemented partly. So you can get the whole chain, so to speak, there. We will do another example, especially during the last half of the course. We will have a bigger example that we will analyze, design, and implement during the lectures. That said, if you don't feel that comfortable programming, have not been programming during the summer, for example, do brush up. Prerequisites for the course is one object-oriented language. So you should not have any problems with the syntax of your language. You should be able to write if statements, while loops, classes, operations, attributes. That stuff should be familiar to you, because programming is the language that we all speak. So a lot of you will understand analysis and design by looking at code, and that is how I will explain stuff. So if you feel uncomfortable programming, take a look at the C# course or your Java course or what you have done previously and brush up as soon as possible. There will be a lot of programming during the lectures and also in the workshops. So we have a few workshops that are maybe somewhat special for this course. You could look at them as somewhat larger laboratory exercises. They are stated down here. And you can read up about them on the course homepage, of course. What is maybe a little bit special is that you can do this in groups, small groups, 1, 2, 3 people in each group, no more than 3. You form these groups yourselves. You can change groups during the workshops. You can change groups for different grades also. So if you want to do workshop 1 with 3 people for grade, the passing grade, you can do that, and you can switch groups for the next level if you want to. Maybe someone in the group is satisfied and only 2 continues to the next level. That is fine. So you work in groups, you develop something, and then you hand it in to me. I will redistribute this to 2 other groups that will make a peer review of your work. That is, they will look at it, comment on what is good, what is not so good, what should be improved. And you, in turn, will also receive 2 groups' works to peer review. So you will write a small protocol and hand it to the group that you have reviewed. After that, you have some time to improve your own workshop, your own solution, if you want to. If you agree to the comments that you have got from the groups that have reviewed your work, you are free to change, improve. And then there is a final hand-in deadline. So for each of the workshops there are 3 steps. Do the work, do the peer review, improve, hand in for final grading. And this process is done for the passing grade. So this is something everyone must do. And during the course there will be deadlines, final deadlines for all 3 workshops. And the goal is that you hand in to a passing grade before or at these deadlines. So at the end of the course you should pretty much have a passing grade in the course. You collect your work in something that I call a portfolio. And this can just be a GitHub repository where you collect your models, your drawings, your code. It could be a homepage where I can download a zip archive or something like that. Something that is easily accessible for both me and for the groups that are supposed to review your work. Something online. After each deadline, I will also present an example solution. The way that I would have solved this problem with some comments, and this will be posted on the course homepage, so you can take a look at it. But then you have already handed in and hopefully got a passing grade. You can check out the assignments, workshop 1, 2, 3. You can prepare by looking at previous year's lectures, read the book, and you can start immediately actually on these workshops. No special tools are required. You will be needing some kind of development environment for workshop 2 and 3. I will be giving you some code for workshop 3, so you will get code for Java or C#. If you prefer something else, it is up to you to translate to that language. And you are free to do so if you want to. I don't have any special language in this course. During the lectures I will be using C#. Last year I used Java, so you can look at the lectures from last year if you prefer Java. You are free to contribute to the course GitHub repository if you want to. Maybe someone is interested in Python or some other object-oriented language, and you can translate the small examples that we do on the lectures to Python and post them on GitHub for everyone to see and enjoy. Regarding language, nothing is really required. I recommend a strongly typed language. C#, Java, excellent. C++ will suffice if you want to. Python is good. Anything that is object-oriented will go. I don't recommend PHP because it's not strongly typed and will cause you more trouble than it's worth. But if you want to do PHP, it's fine by me. I don't recommend anything web-based. I recommend simple console applications for the workshops. The focus is not making a fancy user interface. The focus is doing solid analysis and design and implementation of that analysis and design, not doing a fancy user interface. So that being said, you can read about this on the course homepage. And if I log in here, you can just take a look at maybe the second workshop. It's looks like this. You can read the requirements for grade 2, that is the passing grade. And it's a bunch of requirements and what you should have in your portfolio, and that you should do some stuff. And then you have a higher grade, requirements for grade 3, and a final level, requirements for grade 4, where you have to do some more work. So first you do it for the passing grade, and then you opt in for higher grades if you want to. The deadline for the higher grades are at the end of the course, so you can start a little bit later on the higher grades if you want to. You don't have to work in sequence. You can work for a passing grade for the first 2 workshops, and then for higher grade on the 3rd one, and then go back and make a higher grade for the 2nd workshop, for example. So the goal is to get a passing grade first, and then opt in for higher grades. So basically you decide yourselves what grade you want in the course, the level of commitment that you would like to have. So, and then we have a couple of deadlines. I hope I have got this right. Basically, you have the first deadline at the 14th, so it's quite soon, in 2 weeks, I think. So then you hand in for the first submission for passing grade in workshop 1, and then you're supposed to be making your peer reviews in about 2 days. So you get 2 groups to check out, make comments on, and then you send your feedback to the groups, and also send it to me. And then we have a final submission, so you have like 5 days to look at the feedback you get and make changes. I think that's basically over the weekend there, so that's why we have a couple of more days for the final submission. And this pattern is repeated for all 3 workshops. Hand in, review, submit. And we have a final workshop at the 13th of October. If you get some fixes on your passing grades, you need to fix stuff, you have until the 13th, and also the higher grades, if you go for a higher grade in some workshop. And if you miss something, maybe your workshop number 2 is so bad you don't pass it, or you miss the deadline, then we have an extra task, the Yahtzee game. This is quite a large task, so I don't recommend missing anything. And you need to pass this if you miss any of the workshops. So for example, you do workshop 1 and 2, but miss workshop 3 for some reason, you have to do the Yahtzee game. I will take into account your workshop 1 and 2, but you still need to do the extra assignment. This is not a small assignment, so don't miss the deadlines. Make good quality workshop submissions. Any questions on the workshops so far? I think we will start next week with the workshops. So the first workshop is not really that big. You can start forming groups and start working on it immediately. You can prepare by looking at the literature, looking at the old lectures, and of course attending the lectures this week. Anything else? We have a schedule, you can check that out. We have the Slack forum, I will try to look at it regularly. We have of course a syllabus, you can check that out also. We will be doing a final exam, a small take-home exam that you will do individually. So you do workshops in groups and you have a small final exam towards the end of the course. I have not really decided yet on exactly when, probably 1 or 2 weeks before the course end. So after we have had the lectures, we will do a final exam. But more information about that will come. yeah, maybe we should. You can read about the peer review process. You have some instructions for each workshop, what you should be looking at. Last year, the peer review process was, well, it was okay, so we will try to improve on it this year. Some people got bad feedback, of course. There is always a chance that you get a group of lazy students that give you feedback, and that feedback is not that good. So that's why we do have 2 groups. So hopefully you get good feedback from at least one group. And a little bit, I will be a little bit more stringent on the reviews that you hand in. They should be of good quality also to get a passing grade on the workshop. So you need to make an effort. And one new thing for this year is that you need references in your peer review protocols. So you cannot just say, we think that this is bad, or we think that this is good. You need to be able to motivate why you think it's bad and why you think it's good. For example, by saying that, okay, Larman on page 54 says that you should do this and that in this situation. You have not done so, and we think that this is bad and you should change it. So give references to your opinions in when you do your peer reviews. You cannot just say, oh, we think that this is good. Done. So you need to get some theoretical background before you do your peer reviews especially. So you know what is a good design, what is good analysis, how should it look. And referencing to my lectures are not such a good thing. Tobias said that XYZ is not a good reference. So find references in serious literature. The course literature is good. You probably have other sources that you can find also. Go for high quality reviews and high quality references. So, any questions on the course stuff? There will be forms for your hand-ins, so there will be a link posted on the I think I will post them on this page. So when this deadline is coming near, I will post a link to a form where you can submit an URL to your work and some information about who has done it and stuff like that. And it will close at 12 o'clock on the 14th, so do submit before that. And then I will compile a list and hand your peer review groups to you. And that will be repeated for all the deadlines. There will be a form link posted here so you can make your submission. I will be using Google Forms, so it should not be a problem. You can find the old homepage if you want to take a look at that. I will post materials and I will post recordings as soon as possible. I will also post YouTube movies on the course homepage. It is not that fun to look at me in regular speed, but I do recommend 2 times the speed and with subtitles. That is always fun. And I do prefer if you come to the lectures, of course, it's more interesting for me to give lectures to people and not to an empty classroom. And for you to be active on the lectures is also a good thing. Ask questions, comment on stuff that you don't understand. If you understand something, tell me to go faster and not blab on about something that is unimportant or obvious. It is, I think, more fun to attend a lecture than to watch a recording afterwards. I tend to look at my own recordings, and well, it's not really that much fun, and it is very easy to just drift to some other page when you have that available. So I prefer if you attend the lectures, of course. But if you cannot do that for some reason, recordings will be submitted. So, on the first, here you can also take a look at the course evaluation from last year, if you would like to do so. I won't go through it, but it is there. You can take a look at it if you want to. The basic changes we do have for this year is better peer review process, and also we will be doing grading during the course, so you will get feedback from me or Nadim, that is during the course, and not one final big deadline towards the end. So it will be a little bit more even, so to speak. Last year we only did peer reviews during the course, and then you did a final hand-in towards the end. Now we will do hand-ins during the course instead, and get feedback maybe a little bit faster from me or Nadim. We do have some occasions during the next week where you get an introduction to the workshops. Of course, you can start before and come with questions during this occasions, and towards the end of the week there is some tutoring if you have further questions or problems. Do prepare for these. They are very short, so I think you have like 1 hour at the beginning of the week and 2 hours towards the end, so you can't really start on Friday and try to do it in 2 hours, I think. But attend these if you have any questions, and do ask them. You are free to ask questions also in Slack during the week or whenever, and I will try to answer them, or your fellow students can answer them also. And it could be some, oh, in workshop 1, what does this requirement mean actually? How have you interpreted it? And that discussion is fine by me, because all things are not super clear and super easy when it comes to software development. Are all workshops mandatory, and are there more mandatory lectures I should know about? I'm in California and I have these in the middle of the night, so I want to know when I need to attend live. Actually, you don't need to attend anything live if you don't want to. If you just stick to the deadlines, you are good to go. So I'm not envious. Well, I think that's about it for introduction. Check the time. We do have some more time. That is good, because now we're going to talk a little more about what the course is about. So the name is Object-Oriented Analysis and Design Using UML. Anyone knows what that is? That's good, because if you did, you would not need to attend the course. So, the first thing I usually speak about is when do we use analysis and design in software development? Do you think you have done analysis and design already, maybe? So what do we need to do to develop software? Well, we need to have some kind of idea, identify some kind of problem, some notion about, okay, what are we actually going to do? Maybe we come up with this ourselves, or maybe someone else tells us what to do. We have this problem in our organization, we would like to solve it in this way, we would like to have these functions, the system should be able to do these things. in software development language, we call these requirements. So we need to have some form of requirements. You have probably already got requirements in many of the courses that you have been attending. For example, in your programming assignments, you have, oh, you should make a program that does these things. I don't know if Mats still uses the recipe database application in C#. Yeah. So we have some form of requirements. What the system should be doing, what kind of problem it should solve. That is a good first step. We cannot just start without knowing something at least about what we're supposed to do. Someone knows anything else that we need to do to develop software? The exact same response I got last year. No. Maybe I've already said it. You need to do some kind of programming, I guess. Because without coding, there won't be any software. So we need to do some kind of implementation, we call it. This could be programming, could be making pretty pictures for buttons, could be database stuff, whatnot. Things that we need to do to actually get a software running. So we have some requirements, we know what to do, and we have some implementation that hopefully implements these. And what else? Something that you are probably quite bad at. How many of you have handed your implementation to the laboratory tutor or assistant and for grading, and the first thing that they do is find an error? So we need to test stuff. So we have requirements, we have implementation, and we have test. We need to deploy our software in some way. We need to hand it to the end users, give it to them in some way. So we need to deploy. And can anyone guess what the gap is for? Testing, yeah. Analysis we have here. Yes, of course we need to do analysis. Planning, exactly. We need to have some kind of planning. I won't take that up, but it is an activity that we need to do, especially in a group setting. And design. So you have probably been doing analysis and design already, because it's often quite impossible to just start implementation without at least having an idea about how am I going to solve this. Well, I'm going to use a function, and I'm putting that function in the class, and I'm calling this function from another object, and stuff like that. So you have probably already been doing a design in your own head. Maybe some of you have been scribbling down something on paper also. But you have at least an idea on how to do things before starting to do them. You cannot just sit down and start typing if statements at random. You need to have some kind of model, at least in your head, on how things are supposed to work. So, and analysis is about understanding the requirements as a whole. So if you have a lot of requirements, it can be hard to get an overview and hard to put them in a context where they belong together. You just have a list of statements. And to understand these in their own context, we do analysis, and we do design, and we do implementation, and we do test, and we do deployment. There are, of course, other activities like planning, project management, and stuff like that. So, but this is the basic steps that you have all gone through, I think, when developing a software. If we do this in sequence, we have a process called the waterfall model. We do all the requirements, we collect all the requirements first, and then we do an analysis of these requirements, and then we do a design, full design of our software, and then we do a full implementation. And then we do a big test, and then we do a big bang deployment. This could be a good process in some cases. Maybe you have a very short project, maybe just 2 or 3 weeks. Maybe the requirements are really, really well known, rigid. You have done 500 systems like this before. You can basically, you know basically exactly what the customer wants. If you have insecurities, however, in your problems, in your requirements, you probably need to take another approach. You need to be more iterative, and you cannot fully define all requirements from the beginning and do full analysis, full design, full implementation, full test. You need to take it bit by bit. You need to work incrementally and iteratively. So in that case, you do, I'm not really sure on how to draw this, but if we instead draw a diagram like this, and we do some requirements work, and we will probably do a lot more requirements work in the beginning, because we need to understand more at first. We need to understand the problem and what to do at first. And consequently, we will probably do a little bit more design in the beginning, but we need something to design first, so it's a little bit offset. I like design, so we are going to do a lot of design. But it's more towards maybe the first middle of the project. Implementation, a lot of implementation. Implementation is good. This is at least the ideal situation where you have a lot of implementation during the middle of the project and can kind of like taper off towards the end. Looking at many student projects, it is more likely to be oh my God! Deadline approaching. Try not to do that. And testing. We don't have so much to test maybe at first, but testing will probably rise and be more and more. System will grow. More effort in testing is needed. And deployment also. We don't have so much to deploy at first, but more towards the end. And at any given point in this, have time like this. At any given point, we do a little bit of everything. So at this point in time, we will be doing some requirement, not as much as in the beginning, but at least some requirements. We will maybe collect details on requirements, or find problems in requirements that needs to be attended. Feedback from our users that needs to be handled, managed in some way. Maybe we need to do a little bit of analysis to understand these changes. We need to know how these changes fit into the design of the system. We need to implement them, write test cases, and do deployment. And then we do all this again, and the system kind of like gets a little bit bigger for each iteration we do. I don't know if you recognize this diagram. It is in the book, and he writes a lot about the unified process and where analysis and design fits in. So analysis and design fits in during the whole project, but with a focus maybe at the first half. So, okay, we now know when design and what we need to do. But why do analysis and design then? No. So, why analysis and design? Yeah, to save time we have here. And someone said maintenance before, so maybe we have this this system already present. And can anyone find the problem in this system? Yeah? Or find the bug, or extend it, or expand it, or even understand what it is. This is what the CPU needs, what it gets. This is machine code from an executable file on the Windows system. So this is what the CPU needs to have in order to work. It cannot do anything else. It's a hexadecimal machine code. Anyone been programming in machine code? Maybe in Växjö you have had some more hardware courses. Yeah, assembler. Anyone programming in assembler? It's basically machine code, but you have small words instead of numbers and letters. So you can do some add, mul, move, and stuff like that. So, but it's not that easy to understand this for a human. But in all systems, this is what needs to be produced at the CPU level. So often we don't work at this level of a system. So this is maybe something that is more common to look at. Code. And sure, you can maybe understand something here. Okay, if something failed, I'm supposed to do something here. But it's not that easy to understand what this is anyway. You can understand the details here, maybe the syntactical details, but it's not that easy to get an overview. And if you look at the number of classes in this project, there are quite a few. So understanding how this system actually works is challenging, at least from this perspective. It's almost impossible from the assembler level, and it is hard from even source code to understand at a higher level. But then again, if we have something like this to describe the system, maybe we can understand at least the higher aspects of it a little bit more easy, if we have knowledge about what these arrows and boxes actually mean. So this is called semantic gap, the problem of a semantic gap. So at the far right here we have the CPU. Pop, pop, pop. And at the far left we have a dude with an idea. He has the requirements or a problem or an idea of what to do, and we need to translate this into the machine code. F0, A, B, 1, 2, or binary. That is not so easy to do. So we have a high-level language before that, where we can write stuff like if statements and and things like that. So we can at least have a compiler or interpreter to transform into this CPU level, so we don't need to worry about that at least. But as you saw, we also have this design to facilitate a higher level of understanding and higher level of reasoning, and in some cases also adding quality, adding efficiency to our projects. We can reason about how to achieve performance and security at a high level instead of at a low level. We can schedule work more easily. We can divide work more easily if we have a good design, a good blueprint of what to do. Okay? All houses are almost built with blueprints because carpenters and plumbers and electricians need to know what to do, and they need to not collide when they work, and they need to do things in a certain order to make things happen in an efficient way. Or you need to tear down stuff that someone else has already done in order to get into the wall to plug the socket in or do the piping. And we can do some analysis to understand the requirements better. Maybe something like that. So we take the design and transform it into implementation. We transform the analysis into a design, and we transform the requirements into an analysis model. So instead of taking this giant leap, we take small steps instead, and we can add good things during these steps because we can reason about things at a higher level. We don't need to worry about, oh my God, is that supposed to be an A or a C? And this requires intimate knowledge about CPU architectures and stuff like that. While understanding this maybe you need very good understanding of banking systems and interest rates and loans and lendings or insurances. Quite different areas to be experts in. And that is one of the challenges as a software developer. You need to be good at this side, and you need to be good at this side. You need to understand entirely new problem areas. You cannot just sit and do blogs and image galleries for the rest of your lives. Some of you will definitely work in banking, manufacturing, or you will work in ordering systems, warehouse systems, air traffic control maybe. Lots and lots of different problem areas to understand. So you need tools to transform these problems into something that you can understand and work with all the way to this level. Because you don't have time to be experts on CPUs if you're at the same time supposed to understand something that is quite hard in itself. So also we have the opportunity to find errors. Requirements are, as you probably know, not perfect. When we put them in context with each other, they are bad, incomplete, lack detail, contradict each other. So if we find this as soon as possible, before these problems enter the product, it is good. And the same thing during designing. Okay, how is this actually going to work? How are we going to make a software out of this? It is good to find problems here first before they enter implementation, and we have a lot of code to maintain. And if we during implementation realize that, oh my God, this is not going to work, it is good to find out before we have 500 programmers hacking away at our system. And this is what we want to avoid: bugs in our shipped product. So that is why we need analysis and design. I will do a final one a little bit fast. I think time is running out and it's time for a break, but we will do a short thing on why object orientation. Why do we do object-oriented analysis and design then? We can do analysis and design in multiple ways, and but this one is called object-oriented analysis and design. Basically, as humans, we understand the world through abstraction, encapsulation, and hierarchies. That is how we see the world. We don't look at every minute detail in every situation. If you look out, you say, well, I see something green, I see something brown, oh, a red car, but you don't really look at all the leaves on the tree. You don't look at every straw of grass and appreciate the details in every little aspect of life. Maybe we should do some more, but we don't. We abstract. We look at the details we need when we need them. Otherwise, we just focus on the big picture, because there are probably too many details in our lives all the time. So we cannot focus on everything. I cannot look at the spot on the desk and look at that little one and, oh, maybe he has something to say. Or I see, oh, a bunch of students, a gray matter. So we work with abstraction, and we do that really, really quickly. If you look at small children, they are really fascinated by details. They can watch a little beetle or a grass straw for hours and hours. But as we grow up, we kind of like use abstraction instead, to focus on what is important to us at the moment. So encapsulation is also something that we do to manage complexity. How many of you have a driving license? I think maybe at least most of you do. But how many of you understand how a combustion engine works? Maybe someone does a little bit. And that is not that strange, because they are really complex. And by using encapsulation and a standardized interface, with a driving license you can drive almost every car. You know the steering wheel, you know the gear shifting, and you know the pedals, and a little bit more. And you can drive every car without knowing anything at all about combustion engines. So encapsulation is something that we have used to package complex things, put an easy-to-use interface on them, and then we can let many people use them instead of only experts. And last but not least, we like to form hierarchies. And this has to do with both abstraction and encapsulation. We form whole and part hierarchies. We know that a car is made out of wheels and driving and seats and stuff like that, and an engine. So we have a whole and we have the parts of the whole. And if we have knowledge about an engine, we can reason about the engine in the car and maybe the engine in a motorcycle. If we have knowledge about leaves on a tree, we can reason about the leaves on a tree on a bush, because they are the same almost. So we can deconstruct things by breaking them apart in hierarchies, whole and part hierarchies. We can also form is a type of hierarchies. So using abstraction, I can see that, okay, there's a car outside. Going down one step in detail, I can see that it is a red car. It is, I think, maybe a Saab, maybe? I cannot really see from here. But I can reason my way down. And I can also reason my way up. Okay, a car is a vehicle. I can see other vehicles here. I can see bicycles. Maybe if we are lucky, we can see an airplane. So we form these hierarchies that allow us to reason about things at the right level of abstraction. If I need to go somewhere, for example, Gothenburg, I need a vehicle. I could possibly go by bike if I have a lot of time. I can go by train if I have even more time, or car if I have one, or plane, or something like that. So we use these concepts in our daily lives to understand the reality that we are in and not be drowned in details about stuff. So object orientation builds on these things. We add the ability to do abstraction, to do encapsulation, and to do hierarchies in object orientation. And that is why object orientation supports human thinking. So object orientation is supposed to make things easier for you, not harder. At first it will probably seem a little bit harder, but hopefully, at least after this course, it will seem more easy and more natural. So the idea is to use the way that humans think and understand the world also when we do analysis, when we do design, and when we do implementation. So object orientation is there to make things easier for you, not the other way around. Okay, one last wiki. UML, that is the last part of the course name. Unified modeling language, a visual language to make models. It's unified because before the UML we had a lot of different types of languages, and we had the language wars. When I attended the university, we had a plethora of notations to use, and you never knew really which one you were supposed to use, and you mixed and matched. But some bearded guys sat down and they constructed the UML instead, and it has been maintained by the OOA, the object management group. So there you can download the standards and you can take a look at the details. It's quite detailed, it's quite large. We will only look at a subset during this course, the subset that supports analysis and design. And there are millions of details and stuffs you can look into UML. You can model not only software, but processes and a lot of things. But it is visual, and this is also important because that also supports the human brain in a good way. We are quite visual creatures. We don't really spot details and errors in text, but in visual diagrams we can see things more clearly. And it's not a process. So you cannot develop according to the UML, but you can use the UML when you develop, if you want to. And we can use the UML at different levels. We can use it as very finely detailed blueprints, or we can do more sketch-like things. And we can do modeling before we implement, or we can do modeling after we implement. Possibly you get an implementation that has not got a design, or the design was thrown away, or the implementation deviated from the design. So it is good to be able to know how to transform a design to an implementation, but also how to take an implementation and make a design out of it. That is stuff that we will practice during this course. So, questions? Okay, I think it is very much time for a break. So 15 minutes.